we did not show you the first part of this application and my idea so far of the architecture. So we're going to have the load, and these are the standard images. These are ones that have been AI generated from Google. There's some that have been found in the amazing group of artists at Unsplash, some around my Victorian home, and we'll add more of those. But first, we get a batch load, loads the standard ones or any ones you want for a directory. I've also done it from pulling from another S3. We'll see there. So what happens is we'll load the data. We have a lot of embeddings. You see 4 different ones. And we call, thanks to a llama, we call a lava model that looks at the image, gives us a really nice description, and we store that in a couple different fields with a couple different embeddings. So we have different ways to search things. Fun. We run this all in a Jupyter notebook. Though if I do get a bulk supply, like if I get contacted by perhaps a paranormal researcher and they want to load 100,000 files, I'll put this on my Ubuntu server and we'll do that. Or put it on the other server I got running over there. Now that it's getting cool out, I can run my server. Doesn't make my room too hot. Still working on the capture one. I've got a couple different Raspberry Pis for that. Also, some NVIDIA might be a little too powerful to put inside a ghost trap. And then I have a Streamlit app, which is in rough form, but has been successful to do sighting entries, for people out in the field. You see something, you take a picture, put in your quick report, you upload that to Milvus. Started the Enterprise app with LangChain4j and the Milvus SDK so that you can work against this data. And setting up a bunch of analytics, different types of search, hybrid search, filtered search, prefix, infix, lots of fun stuff there. So we've got that started. We've got it started in a GitHub, which should be linked in the first of the article series. But let's go through it. This is the notebook that is in GitHub. It's got a little docs here. These are 2 of the prompts I used to generate some of the images, and you got links to the stuff. Highly recommend the Tobin Spirit Guide, good source of information, and some background on some of the models I used. We have some stuff in the environment, or if we don't, we probably should. And then here, this one is pretty important. So make sure we go through this one pretty well. I'll make this a little bigger. It's going to stink developing on something this big, but whatever. So bring in all the Milvus stuff, and I've got a bunch of embeddings. I'm doing the BGEM3. I only have a CPU. You don't want to use FP16. Don't need to be that compressed, but that's something we can play around with. And I'm only using it for dense, just to show the art of the possible. I could do a second sparse model and use BGEM3 for that. Think about that. I'm using Splade for sparse. Again, I could use that other model just to show you. I can use many embedding models as I want because we could have up to 10 vectors. Now, if you're using it out of the box, it defaults to 4. If you want to change that, you have to go into settings. We could show you that in a future one. So we're using Clip. Clip is awesome. And Clip will let us search our ghost by text or by an image. And we're going to do that. Also, I'm trying one of the Alibaba GTEs here, just the base one. So we have that model. So again, a bunch of different encoders there just to give us different types of embeddings, different vectorizations. It's fun. Now, this is bulk data. I should have a CSV somewhere or another database or Kafka or Pulsar or something that has all of this rich structured data for our reports, and probably in the Analytic Java app or one of the other ingest apps will do that. If you've got suggestions what you'd want to see, I know we just did the talk with Stream Native, and we just did the awesome talk with Datavolo. Maybe I'll talk to them if they want to help me catch some ghosts. I think they might. But for now, I'm using Faker to create some of the sighting information. And obviously, when you use the sightings app, use your real information. This is serious business. We've got some different categories of ghosts here. And again, doing the research from the materials that came in handy. Make sure we ran that one. I need that categories. Then we set up some Milvus stuff. This is on one of my local Linux servers over here. You could obviously run this local. You can run it in Zilla's cloud. You could run it in Milvus Lite local database. Choose which one you want. With this many embeddings, probably better off using a whole Milvus cluster, Zilla's cloud, or something of that powerful. But we're doing it with just a Docker one, which is a nice standalone cluster. With but it has Minio, which is important for me because I need that for something else. So we connect to that one. We connect to Minio on S3, which I have over here, because I want to put my images somewhere that I can use them anywhere in my cluster, regardless of where we are in the world. I'm thinking Meetups. Okay, so we connect to the client. I am connected to Milvus here. Milvus we have running over here. Hi, Milvus. And I got a couple different dimensions here. My collection is the imaginatively named ghosts. I don't know if I should do plural or not. As a data engineer, maybe it should be singular. Maybe it should be a longer name. Maybe we should do like SAP and have a long uppercase German name. I don't know. Let me know, data engineers, what your thoughts are there. Maybe we should start coming up for best practices for naming. Obviously, I'll put this in my own database. It's in my own cluster, so it doesn't matter. But, if you're going to have tens of thousands of collections, might think of standardizing in names. So we've got different classes that are, the standards out there for classifying ghosts, plus a couple I thought of as, that might make sense for certain circumstances. Now, there's two different Milvus Python APIs. I'm using both because Hybrid needs that right now. No, there is a new version of Milvus out, so I got to check that, see if it needs it. Then we're going to define all of our fields, and obviously need a primary key. Ghost class, we just saw that there. File name, important for those images. S3 path, so I can get anywhere. Description, as you can see, this is big. This is the one that's generated or you typed in. I give you 64K there. You should be able to type in a decent amount. We got categories, some kind of identification, location. I don't know if I should make this a full thing here with street and all this other things. Let me know how detailed you want. Or do you want me to point to another database or another collection? I'm still debating that. Country Latin long. GES stuff is coming natively to Milvus soon. But for now, it's just a string. Got some timestamps. And our first vector. This is our clip vector. This is going to be an image that we can search with text or images. Then we've got, based on that description, 3 different floating vectors for them. 2 of them dense, 1 of them sparse. Just to give us some different dimensions and codings. Fun stuff there. So we create that collection. And for performance, partitions. Because I know approximately the main classes, though I did add some more classes. Maybe I should make that 12 or 16, but for now we added the 8. I checked to see if I created the collection. Don't need to reconnect it. I don't want to drop it. So I create it and prepare index. This one's important because put an index on ID, always good. Ghost class, because there's such a limited number, and we're going to be using that for a lot of queries. We had a try for that one. Zip code, inverted index, again, limited number there. Vector, cosine, that's how we created it. We got the sparse, inverted index, IP for the first text vector. Cosine, because this is a regular one, and then we've got a flat. So we've got a lot of options. We'll see which makes sense, which is faster for querying. Again, this is a good way to test this out. Then we load it, and then we get the collection ready for the hybrid search later. Now I've already run the standard load, and I don't want to run it again. It does take a while because we're calling that Ollama model to Lava to generate text from the image. It takes somewhere between 5 and 11, 12 seconds on my laptop, which isn't super fast. That is the slowest part of this. And then we upload the image to S3, iterate them all in the local directory. Here you can see we're using Ollama Chat to get the image described. I tried Nemo before, and the results were faster, but they weren't quite up to it. They were okay. Sometimes they were wrong. So I switched to Lava, and that seems to be a lot better. We make the description as this. We could combine it with other stuff. We get the timing there because it takes a while. We do the embeddings on all those images we just iterated through. And then we just loop through all that data, except for some that I'm just going to fake, or in the case of categories, randomly pick them randomly. Then we'll run our 3 text embeddings there. Whether it's Alibaba's Splayed or BGM3. And then we insert that into the collection there. For the BGM3, remember it gives you dense and sparse, so we got to make sure we pick the right one. And then we put the time there. You can see about how long. First one, obviously it's warming up, takes a little longer. Some of the images are a little faster. You can see the ones that came from the awesome Unsplash. Great artists on there. Definitely support those artists. They do some really good work. And there's some really cool ghostly pictures there. And then we've got 7, 8, 9. And then total, it took a while. We got our 47 rows. Pretty consistent. I may try to do the bulk loads on one of the Unix machines, but we'll see. So we've got our data loaded. These are the standards because we need these to compare others. So when we upload, we could say, hey, that's not a ghost. Do you sure you want to upload that? Good for ghost detecting. So here I'm going to do a text search. So ghost with a skull head. And then I embed it using clip. And that's going to be our search. And I'm doing a filter. Keep it to most of the real classes. Maybe we should do all the real classes. I don't know. Limit to 10. Search in that vector field, that image. I just need 2 things back. I'm going to iterate through them. Show the image. Oh, I got that twice. And show it a couple different ways. And then make a combined image of all those images. But let's, we can run that one. That one don't take too long, yeah. See, here I was showing all the individual images, but that takes up a lot of space. It's nice to have this final one here, which looks kind of cool. This might be a good, interface for a ghostly website. Pick your ghost there. Okay, then the next search we're doing, again, testing. This one is my check for later to see if something matches as a ghost. So I tried it with my cat. Cat is not a ghost. He's just a cute cat. And then one with a ghost. Just to give an idea, I should hook this up to one of the integration tests and go through a whole bunch of images. See how accurate we are. And then we just do a search. And I want to get one back. If I get one that is close enough, near enough, and similar enough, then yeah, that image is a ghost. That's pretty creepy. I think that's a ghost. So that works okay. Again, these are small tests. Then we're going to do a hybrid search, and we're going to do a weighted ranker because I figured that's a cool way to do it. Creepy skullhead ghost. And we get our queries ready. I'm querying our image with that text. And then I'm querying the text model with that query. Then I'm doing another one with one of the other text ones. And then I'm grabbing an image. And I'm using that to search the clip image. And I'm throwing in the BGM3 one. So we have 5 different queries together. And we write a time on it. Give us back 10, hybrid search, pretty quick. Let's show the results here. Again, pretty quick. I decided, as thoughts of those future analytics, we do our query, which we could filter, to do a simple report, grab back all the fields, display them as markdown, put a small image in there. Let me make sure I ran that. Yeah, it runs pretty quick. And it's pretty nicely formatted. And you can see that the generated descriptions, not bad. See, we should change the classification. This one seems staged. You know, this is probably fake. So we should probably change that class to fake. And then you got an environmental one. Couple different results back. You know, just to show you the art of the possible. And we've got all that data here. Like I said, this is a pretty big... Oops, wrong one. Ghosts, how about that? A lot of fields here. We've got the 4 vectors. We could do a quick search here just to take a look. Maybe we just want to show ghosts of a certain class. We don't have too many loaded yet. So we probably don't want to do all of them. Let's do ghost class equal... Hello. Ghost class. Did I break my machine here? Oh, I made the screen too dumb. The screen size is not good here. Let me get back to normal, and then we could do that. Okay, so ghost class equals... no, I must be running too much stuff here. Let's just look at the regular data. And we could do a limit in here. Just do the ghost class. Have to reload this. No, wait for that. So you can see we got a ton of data here. We could filter it, limit it. We got to reload this. I don't know if there's something going on my network here, or I screwed things up when I resized the screen here to be super large, make it easier for you. So we want to look at class 3, which we don't need all of that. So we have a couple of class 3s loaded, and we could grab the image to take a look at it, see the description there. Like I said, we have these images here in our Minio, so we could take a look at them pretty easily. Thanks for checking out. Next one, we'll show you the sightings app. That is almost there. Code is not super clean. I got to clean that up and work on some other things, but we're here. Works pretty good. It's nice to have all the different options with the different vectors. So, thanks, and definitely check out the application. We'll have more stuff going on. And Halloween, we got big trick-or-treating here where I am with my 12-foot skeletons. So we may be able to do some live captures on Halloween. We'll give that a try.